Hi all, in today's video we're going to be looking at the final part of the course, which is when we can use trigonometric identities to simplify or indeed prove some statements. Now in National 5 there are two important trigonometric identities which we are expected to know. However, for this year there is one major one, but I'm going to include the second one so that you are aware of it, okay, especially if you have the intention of moving on to higher, you will need this, okay. But the two formulas are true for all values of x, so it doesn't matter what value of x I put in, there's two things that will always be true. Okay, so the first thing that's always true, and if I get to my highlighter here, this is the main rule we're going to be looking at today, is that tan of x is always sine of x divided by cos of x. Okay, now I have explained that in front of a few of you before in the last couple of weeks, but the main thing is to know that is the rule that's always holding. Okay, so the definition of tan, it's sine divided by cos. Okay, so if you want to know the value of tan at a specific point, you do sine of that point divided by cos of that point, you get the tan value. Okay, that is the major rule we're going to be using today. The other rule, which isn't going to be important for us today and your questions, but you know, it might be important for you next year, will be important for next year if you pick higher, so I'm letting you aware of it just now, is that sine squared plus cos squared, no matter what the values of x is, that will always equal 1. Okay, so that's the secondary one. That's not the one we're going to be using today, but I want you to be aware of it. Now, we're going to look at one example in your notes, and I'm going to give you a second example for you to copy down. Okay, but the first example is we're going to be asked to simplify this expression. So they're telling us we want to simplify what tan of x is multiplied by cos of x. Okay, and we're going to look at how we do that. So the main thing is we're going to use our rule, okay, and what I'm going to do is I'm going to swap, using my rule, what tan of x is, because I know tan of x is sine of x over cos of x. Okay, so I'm going to swap tan of x for that. So that's going to equal, my expression will equal not tan of x anymore, I'm going to swap tan of x for sine of x over cos of x, and that is multiplying cos of x. Okay, now what I'm going to do is I'm going to make cos of x into a fraction so we can see what happens a bit clearer. So I'm going to have sine of x over cos of x, then I'm going to multiply what cos of x is over 1. Okay, so if I want to make cos of x a fraction, I just make cos of x over 1. Okay, when we multiply fractions, okay, the two numerators multiply together, so I get sine x multiplied by cos x, and that's going to be divided by cos x times 1, which is cos x. Okay, and the question asks us to make sure we are simplified, so you can see here from using our algebraic fraction skills, I can cancel a cos of x on the top with a cos of x on the bottom. Therefore my answer becomes sine x on the top. I would still have a 1 on the bottom, but we know if we divide by 1 it stays the same thing, so that expression would just simplify as sine x. Okay, so there's an example of when I used the rule to change the tan, and then I had to work out how to combine my answer, simplify it, and what I'm left with is an expression sine x. Okay, so this is the first example that's in your notes. I'm going to ask you to make sure you copy that down, so pause this video at this point if you haven't done so. Okay, we're going to move on to the second example now. So another type of question is, rather than simplify, is we need to sometimes show that. Okay, so here's an example of when we're asked to prove something. We need to show that if I multiply sine, cos and tan together, what I end up with is sine squared x. Okay, so that means sine x squared. Okay, so let's see if we can use our rule to do that. So again, I'm going to use the rule for tan. So my rule is, I'm going to actually copy this one down in your notes. Okay, so the second example in your notes we're not going to do, just write over it with this example. It's going to be tan of x equals sine of x over cos of x. Okay, so I'm going to swap this tan of x with sine x over cos x. So that's going to be my first step. So if I write this out, it's going to be sine x multiplied by cos x, so they're all joined together, multiplied by tan x, which is sine x over cos x. Okay, now what I'm actually going to do, I'm going to write this as LHS. Now why you might think that is, what I'm going to try and do is I'm going to try and deal with the left hand side. That's what L, H and S stand for, left hand side, and my aim is to work with this side, and then when I eventually prove that this ends up as sine squared x, I'll then be able to say that equals what the right hand side is. Okay, and that's me proving what I was asked to show. Okay, so my left hand side so far, I've changed the tan for sine x over cos x. So again, like what we're going to do above, we're going to have to multiply this. So I'm going to change everything to fractions just to make my life easier. So I'm going to have sine x over 1. That's going to multiply cos x over 1. And that's going to multiply sine x over cos x. Okay, so even though we've got three fractions, multiplying fractions stays the same. We're just going to multiply all the numerators together, then we're going to multiply all the denominators together to work out what's on top, what's on bottom. So I'm going to have sine multiplied by cos, and then we're going to have another sine attached to it. Okay, so that's going to be sine squared. Okay, and the best way to write that is sine with a 2 above, then x. So it's not just sine x I've got two of them multiplied together, sine squared of x. Then I've still got to multiply that by cos of x, so cos x is still going to be there. Then on the bottom, 1 times 1 is 1, times that by cos x. I'm left with cos x on the bottom. Then similarly, like above, we can see we've got some simplifying to do, so I'm going to cancel the cos x with that cos x there. That would then leave me with what's on the top, sine squared x over 1. If I divide by 1, it just stays the same, so I'm left with sine squared x, which is what I was asked to show. I was asked to show that this thing at the top, sine x cos x tan x, did equal sine squared x. I've managed to prove that by using that rule. Eventually I get sine squared x out, that equals the right hand side. Okay, so what I'm saying there is I'm showing you that the left hand side did eventually equal what was on the right hand side. I've proven that's what it was shown as. So there's two questions I'm going to actually copy down. Those are the two style of questions you can be asked. You can be asked to simplify, so they give you an expression, simplify it using the rule, or here's an expression, you need to show that it equals something else, okay, and you use the rule like what we've done to do so. Okay, these questions are tricky, folks. You do need to practice these. You do need to take your time with these as well, okay, you can't just rush these. However, I want you to practice them today, and the solutions, okay, are given to you, but if you don't understand anything, please let me know. Okay, thank you.